Welcome to Anatomy Coloring Book, page 159, Reproductive System, the Ovary. This is Dr. Stephen Harkins. The ovary is the place of the origin of the female germ cell, the egg cell, also known as an oocyte or the ovum. When you are born, you already have, the female already has hundreds of thousands, maybe millions of ovaries, of oocytes or ova in the ovaries. And once a month, one or more, I suppose, in the case of twins, is released from the ovaries and travels down the fallopian tube or the uterine tube and into the uterus for fertilization or potential fertilization by the male germ cell, the sperm. This lesson is about how the ovary functions to create and to release those ova once a month into the uterine tube. First, there is a ligament surrounding. The parietal peritoneum surrounds the ovaries and, as you can see here, the uterine tube as well completely. It's like a clothesline that's got, say, a towel draped over it. And you can see how that would leave a sort of a little bump right here where the line comes through. In a similar way, you can see here the this connective tissue surrounding and sort of enveloping the ovary. And this is called the broad ligament right here. The broad ligament and its various parts. One of which is the suspensory ligament of the ovary. It's this area right here, this covering. And as it states, it pulls up and keeps the ovary elevated and pinned against the posterior wall of the pelvis. Attached. And inside the ovary, there is an inner layer of epithelium called the tunica albuginea. And that is just this single epithelial layer on the outside here surrounding the ovary. Of course, the broad ligament is outside of this, surrounding it, the tougher layer, but this is a thin epithelial layer. Now inside where I made all those dots, this is called the stroma. The stroma of the ovary. It's just the general inner area of the ovary consisting of connective tissue. But as I said, inside there are hundreds of thousands of oocytes, eggs ready to be fertilized, and we're going to show that process now. So the oocyte is this little egg right here, right there, and through its process, what winds up happening is it becomes surrounded by a single layer of supporting cells. A single layer of supporting cells, and when it does this, the egg, the ovum, starts to become, as I said, surrounded by supporting cells called follicle cells. When these follicle cells, and this is the process, now the follicles are partially covering, and now they're fully encasing the oocyte or the ovum here in the middle. And that's called a primordial follicle. It's right here. It's the egg surrounded by supporting cells called follicles, follicular cells. So here's the egg in the middle, and then we have the supporting follicular cells on the outside, and that's called a primordial follicle. Now, the purpose of these follicle cells surrounding the ovum is to provide support and nutrients for the ovum to grow and mature so that it can be expelled into the fallopian tubes and travel to the uterus for fertilization. And so after it becomes a primordial follicle, what happens next is these follicular cells begin to grow and grow and grow and grow and grow and get bigger and bigger and bigger as the ovum itself becomes more nourished and becomes a little bigger as well. And so the follicular layers grow and grow and grow. So not just one layer, but 2 layers and 3 layers and 4 layers, you see. And that is called, that is when the ovum becomes what's called a primary follicle. During this next stage, the ovum becomes a secondary follicle. When that happens, a gap starts to form, a little hole right here starts to form right there during the secondary follicle phase. And it's a gap that between the follicular cells. And that gap or that hole is called an antrum. Antrum. Right here. And it fills with fluid called follicular fluid, which is more nutrients and support for the oocyte. But what it leaves behind, and here it is growing in the next phase. Here's antrum. It's called an antrum. As the follicle becomes more mature, a more mature follicle. Here's the antrum here, the space. And note that there are follicular cells now surrounding the outside, but also surrounding the ovum right there. And that part of cells, follicular cells now surrounding the ovum, are called Graafian cells. So this here is a mature Graafian follicle right here with the antrum, a very large mature antrum with fluid in it, and the follicular cells around the outside, and the Graafian cells, Graafian follicular cells surrounding the ovum. Some eggs and follicular cells don't make it past this stage and they die off, and they're called atretic right here. And this is an example of an atretic follicle that has sort of died off and didn't make the cut, and it was not going to be discharged from the ovary, called an atretic follicle. But some do make it. And what happens is the follicle will go to the end of the ovary that is connected to the fimbria here, the fimbriae, these little finger-like projections of the fallopian tube, or uterine, not uterine, yes, uterine tube, and they reach out and grab the egg, or the ovum. What happens is the ovum travels to this area right here, expels the egg, here it is right here, and the fimbriae grab it and take it into the fallopian tube to head down toward the uterus. When it is expelled, what's left behind is this body right here called the corpus hemorrhagicum. And this, after the expulsion of the egg, this body right here, hemorrhagicum, because it causes a little bit of blood and a little bit of, a little bit of bleeding. After a little bit of time, this sort of bloody, hemorrhaging body becomes what's called the corpus luteum, or the young corpus luteum, right here. And so the remaining outer portion of what was the follicle now becomes the corpus luteum. And this becomes important because, and then it matures, because it winds up secreting very, very important hormones to estrogen and progesterone in order to support the fertilization of the egg cell. As the egg cell travels down here into the uterus, these hormones coming from the corpus luteum are going to be very important in preparing the uterus and for fertilization. And it's going to signal the rest of the body that it's time for fertilization, and it's time to prepare for a baby. And even if pregnancy does occur, the corpus luteum still continues to send out hormones to signal to the body for 3 months or so to take care, to prepare for birth and to prepare for the growth of that potential child. If fertilization does not occur, then the corpus luteum will degenerate into a waning structure called the corpus albicans, and it starts to degenerate and fade away. So this area here with these finger-like projections is known as the fimbria. And it is the opening of the uterine tube, or the fallopian tube, which heads down to the uterus. Of course, the ovary is vascularized. It has to have an artery and a vein. So it does have the uterine artery and the uterine vein. And they sort of course through here under the broad ligament, the vein under here, taking blood away. And then, of course, the artery bringing blood to, underneath the ligament here, bringing blood to the ovary. There's a ligament that holds the ovary in place called the ovarian ligament, right down here, connecting as part of the, or underneath the broad ligament. That's the ovarian ligament. And there's also the suspensory ligament of the ovary surrounding the ovarian artery and the ovarian vein. That's this part of the broad ligament here. And a look at it from here, we've got our primary follicle, and then we got the secondary with the opening beginning right in here, called the antrum. Here's the growing antrum with the follicular cells surrounding, and then surrounding here too. Now the corona radiata and the zona pellucida. When the egg is before it's expelled, there's an area of it becomes surrounded by a thin layer of proteins. This is called the zona pellucida. Then it also, in this final stage here, gains an area to the outside of the zona pellucida called the corona radiata. Now, the first area, the zona pellucida, is for protection from, it's going to be traveling down this canal, and it needs to be protected. Now, the zona corona radiata, what it does, it needs to be fertilized as well. The sperm cell cannot get into the ovum to fertilize it because of the zona pellucida. Well, the corona radiata, what it does is when the sperm arrives, it will break down that zona pellucida right there. It'll break that area down and provide an entry point for the sperm cell. And this represents the end of page 159. Anatomy Coloring Book. This is Dr. Stephen Harkins.